So this is a quick video showing you how to use the Fast Fourier Transform of your iOLab. So in the upper left-hand corner of your iOLab, there's a little microphone, and you can talk into that or sing into that, and then capture that information with your iOLab and analyze it later. So let me show you that. I'll turn on my iOLab, and then I turn on the microphone, and now I'm going to click record, and I'm going to talk a little bit and sing a little bit. So I click record, and I'll say a few words so you can see what that looks like, and then I'll do some singing notes. Ooh, ah. And now we've got that information captured, and we want to study it using a fast Fourier transform. Now, a Fourier transform is something you learn about in second-year physics courses, so it's definitely beyond this course, but it is simple enough for us to use. So a Fourier transform is basically a way to see how much of which frequencies exist in a signal. So to access the fast Fourier transform, you click on this little icon here, the toolbar at the bottom, and you go over to the drop-down menu for fast Fourier transform, and there's a range of different options here that will give you different resolutions. So for the human voice, I find that the first or the second one works pretty well. So I'm going to use the second one, and that gives us a second graph down here. And I need to click on this upper graph somewhere to actually analyze what's going on there. So you'll see this little gray stripe here. If I click once, I can then drag that gray stripe around. So this is what the fast Fourier transform looks like when I was just speaking. It's a mess. It's hard to understand. Let's come over here to where I was singing, however. And if I click once, I can then move my mouse around without changing where that gray stripe is. So this is the part of the graph where I was going, ooh, a very pure note. And you can see that down here is that my voice was basically putting out mostly 403 hertz. There's another little spike over here, so there was some other frequencies happening at about 806 hertz. But for the most part, I was making a very pure note, almost like a tuning fork, that just put out one frequency. So it was mostly this one frequency, a little bit of this one over here. So let's go over to the horrible singing. So I click up top and I come over here, and you'll notice something kind of interesting here. There are more frequencies in my voice. So when I was going, ah, I had a little bit of a spike here at 731. There was some over here at 487, over here at 243, up here at 975, and so on. So there was a bunch of different frequencies in my voice when I was going, ah, and when I was going, ooh. It was basically just the one frequency. And just to show you the voice again, when I was talking, you'll notice that there was all kinds of frequencies all across the range. So again, just to give you a general idea of what a fast Fourier transform does, is it tells you how much of which frequencies existed in that sound signal. So when I was going, ooh, that was a very pure note, mostly just one frequency. And when I was going, ah, then I got a range of frequencies, but it was a limited range. So if you happen to be a singer and you can hit notes very accurately, you might want to study what you can do with your voice using your iOLab. But again, to use the Fast Fourier transform, you click this little icon, and then you go to the drop-down menu, and usually the first or the second option is best for measuring your frequencies.